installing a combination service outlet and lighting switch in a single box within an attic space, specifically one constructed with standard 4/12 trusses, is permissible under certain conditions outlined by the National Electrical Code. The primary consideration revolves around the accessibility of the service equipment. According to Article 314.27 Cone of the National Electrical Code, service equipment must be accessible via an unobstructed entrance or opening that is at least 6 feet in height and 24 inches in width. This regulation directly addresses the scenario presented, where the installation is located within 6 feet of the attic access point. To elaborate on this specific installation, several factors need to be meticulously considered to ensure compliance with the National Electrical Code and maintain electrical safety. Firstly, the selection of the appropriate electrical box is crucial. The box must be of sufficient size to accommodate all conductors, wiring devices, and their associated connections without overcrowding. National Electrical Code Article 314.16 provides detailed guidelines on box fill calculations which must be strictly adhered to. These calculations take into account the number of conductors, the size of the conductors, and the presence of any devices such as switches or receptacles within the box. Secondly, the wiring method employed must be suitable for the environment. In most residential applications, non-metallic sheath cable, commonly referred to as NM cable or Romex, is typically used. However, it is essential to verify that this type of cable is permitted in the specific attic environment, considering factors such as temperature and potential exposure to moisture. If there are concerns regarding environmental conditions, alternative wiring methods such as electrical metallic tubing or IMT, or flexible metal conduit or FMC may be more appropriate. Thirdly, the circuit supplying the combination outlet and switch must be adequately protected by an overcurrent protective device such as a circuit breaker or fuse. The size of the overcurrent protection should be determined by the ampacity of the conductors and the rating of the devices being served. National Electrical Code Article 240 provides comprehensive requirements for overcurrent protection. It is imperative to ensure that the overcurrent protection is correctly sized to prevent overloading of the circuit and potential fire hazards. Fourthly, proper grounding and bonding are essential for electrical safety. The grounding system must be installed in accordance with National Electrical Code Article 250, which specifies the requirements for grounding electrodes, grounding conductors, and equipment grounding. All metal enclosures, such as the electrical box, must be properly bonded to the grounding system to provide a low impedance path for fault current, thereby minimizing the risk of electric shock. Fifthly, the installation must comply with all other applicable requirements of the National Electrical Code, including those related to wiring methods, conductor ampacity, device ratings, and workmanship. It is crucial to thoroughly review the National Electrical Code to ensure that all aspects of the installation are in full compliance. Improperly installed electrical systems can pose significant safety hazards, including electric shock, fire, and equipment damage. Furthermore, local built-in codes and regulations may impose additional requirements that must be satisfied. It is advisable to consult with the local electrical inspector to determine if there are any specific requirements or interpretations that apply to the installation. Beyond the National Electrical Code requirements, there are several best practices that should be followed to ensure a safe and reliable installation. One best practice is to use high-quality wiring devices and components. While it may be tempting to save money by using cheaper materials, the long-term cost of doing so can be significantly higher. High-quality devices are more durable, more reliable, and less likely to fail prematurely. Another best practice is to carefully plan the layout of the wiring and devices before beginning the installation. This will help to minimize the amount of wiring required, reduce the risk of errors, and ensure that the finished installation is neat and professional-looking. Additionally, it is important to properly label all circuits and devices. This will make it easier to identify and troubleshoot problems in the future. Circuit breakers should be clearly labeled with the loads they serve, and each device should be labeled with its voltage and amperage rating. When working with electricity, safety should always be the top priority. It is essential to energize the circuit before beginning any work. This can be done by turning off the circuit breaker or removing the fuse that supplies power to the circuit. It is also important to use appropriate personal protective equipment, such as safety glasses and gloves. Finally, if you are not comfortable working with electricity, it is best to hire a qualified electrician to perform the work. Working with electricity can be dangerous, and it is not worth risking your safety to save a few dollars. In summary, installing a combination service outlet and lighting switch in a single box within an attic space is permissible under the National Electrical Code, provided that certain conditions are met. These conditions include ensuring adequate accessibility to the service equipment, using an appropriately sized electrical box, employing a suitable wiring method, providing adequate overcurrent protection, ensuring proper grounding and bonding, and complying with all other applicable requirements of the National Electrical Code and local building codes. By following these guidelines and best practices, you can ensure a safe and reliable installation that meets all applicable codes and regulations. Remember to always prioritize safety when working with electricity and consult with a qualified electrician if you have any doubts or concerns. Furthermore, let's discuss specific National Electrical Code articles that directly apply to the installation of a combination service outlet and lighting switch in an attic space. First, National Electrical Code Article 314.16 pertains to the volume of outlet, device, and junction boxes. This article provides detailed calculations for determining the minimum required volume of an electrical box based on the number and size of conductors, device yokes, and internal clamps present within the box. The calculations involve assigning specific volume allowances to each conductor and device, and then summing these allowances to arrive at the total required box volume. It is crucial to perform these calculations accurately to ensure that the selected box is of adequate size to accommodate all components without overcrowding. Overcrowding can lead to insulation damage, overheating, and potential fire hazards. Second, National Electrical Code Article 314.17 addresses the conductor entries into boxes, conduits, or fittings. This article specifies the requirements for how conductors enter and exit electrical boxes and enclosures. It mandates that conductors must be protected from abrasion and damage at the point of entry, typically by using appropriate cable connectors or conduit fittings. These connectors and fittings must be securely fastened to the box to prevent them from pulling out or loosening over time. The article also specifies the minimum length of free conductor that must be left inside the box to facilitate splicing and device termination. This length is typically 6 inches, but may vary depending on the size of the conductors and the type of box. Third, National Electrical Code Article 314.27 covers outlet boxes designed for the installation of ceiling suspended or paddle fans. While this section primarily focuses on boxes intended for ceiling fans, it provides valuable insights into the structural integrity and support requirements for boxes that support heavy loads. If the combination service outlet and lighting switch are to be mounted on a box that is also supporting other equipment or fixtures, it is essential to ensure that the box is adequately supported and rated for the intended load. The box should be securely fastened to a structural member of the building, such as a joist or rafter, using appropriate hardware. Fourth, National Electrical Code Article 334 deals with non-metallic sheet cable, types NM, NMC, and NMS. This article provides detailed requirements for the installation and use of non-metallic sheet cable, which is commonly used in residential wiring. It specifies the allowable uses and restrictions for this type of cable, including its suitability for use in dry locations only. The article also addresses the proper methods for securing and supporting the cable, as well as the minimum bending radii allowed. It is crucial to follow these requirements to prevent damage to the cable and ensure its long-term reliability. Fifth, National Electrical Code Article 404 pertains to switches. This article provides requirements for the installation and use of switches, including the location, height, and accessibility. It specifies that switches must be readily accessible and located so that they can be operated without difficulty. The article also addresses the requirements for switches that control lighting circuits, including the use of 3-way and 4-way switches for controlling lights from multiple locations. It is important to follow these requirements to ensure that the switches are installed safely and conveniently. 6. National Electrical Code Article 406 covers receptacles, cord connectors, and attachment plugs, or cord caps. This article provides requirements for the installation and use of receptacles, including their location, type, and grounding requirements. It specifies that receptacles must be of the grounding type and must be properly grounded to provide a safe path for fault current. The article also addresses the requirements for receptacles that are installed in damp or wet locations, such as bathrooms and kitchens, requiring ground fault circuit interrupter, or GFCI, protection. 7th, National Electrical Code Article 250 deals with grounding and bonding. As previously mentioned, proper grounding and bonding are essential for electrical safety. This article provides comprehensive requirements for grounding electrodes, grounding conductors, and equipment grounding. It specifies the methods for grounding different types of electrical systems and equipment, as well as the requirements for bonding metal enclosures and raceways. It is crucial to follow these requirements to ensure that the electrical system is properly grounded and bonded, minimizing the risk of electric shock. 8th, National Electrical Code Article 240 pertains to overcurrent protection. This article provides requirements for overcurrent protective devices such as circuit breakers and fuses. It specifies the types of overcurrent protection that are required for different types of circuits and equipment, as well as the methods for calculating the ampacity of conductors and the size of overcurrent protection. It is imperative to ensure that the overcurrent protection is correctly sized to prevent overloading of the circuit and potential fire hazards. 9th, National Electrical Code Article 110 provides general requirements for electrical installations. This article covers a wide range of topics, including workmanship, equipment ratings, and safety precautions. It emphasizes the importance of installing electrical equipment in a neat and workmanlike manner, and of following all applicable codes and standards. It also requires that all electrical equipment be properly labeled with its voltage, amperage, and other relevant information. 10th, National Electrical Code Article 314.27c specifically allows outlets, lighting outlets, and ceiling fans to be supported by boxes designed for that purpose. The critical part is that it aligns with the exception provided the attic has the required access, which means the access needs to meet those dimension requirements that are at least 6 feet high and 24 inches wide and unobstructed, and the equipment is within 6 feet of the opening. All these National Electrical Code articles must be carefully considered when installing a combination service outlet and lighting switch in an attic space. Adhering to these codes ensures the safe and compliant electrical installation.